Homework. You haven't submitted number 33. Okay, so I know this is a little bit hard to read. I'm going to zoom in so you can see a little better. So kind of not in order because of how I put them there. So these are the lesson 3-8 problems. Again, this is what's due today. Any questions on the ones you see up there right now, Nick? Decimals? So they should either be fractions or decimals. Mixed numbers are look a little strange when they're in an equation like that. So I'm okay, like on this one, if you had written that as 0.25x minus 3.5, that would be okay. Don't ever round fractions, but if it's exact, it's okay to put them in decimal form, but yeah, I really don't want mixed numbers. Look at those. Sorry, let me move my head out of the way. I'm going to go over number 49 with you. Do you have any questions about anything other than number 49, Nick? 35. Okay. Unfortunately, I don't think I have the problems for these in front of me. I don't think I put the problems down here for that group. So hold on a minute. Oops. 38, not 35. Let me try it again. Oh, which line is perpendicular? Okay. 3y plus 2x equals 12. Is that what that says? Yep. So you need to find one, yeah, where the slope is positive 3 halves. So just kind of look at those and see which one's going to work out. You can tell right away, B and D, you can see those slopes easily. So just maybe A and C, check which one is going to give you a slope of 3 halves because you want perpendicular. Okay. All right, for number 49, it tells you that that you have a segment AB. M is the midpoint of segment AB. It gives you lengths for AM and MB and asks you to find the length in terms of the value of segment AB. So since that's a midpoint, we know that x squared minus 6 is going to equal x. Now the question is, how do you solve that? That's a quadratic. And those of you that are not in Algebra 2, this material, quadratics, was covered in the spring, probably when you were doing remote learning. So I know that you may not be as proficient with some of this as you need to be. So somebody who's not in Algebra 2, can you tell me how to solve that quadratic? X squared minus 6 minus x equals x. Sorry. Okay. Okay, you could do a quadratic formula. What's another way to solve a quadratic? Quadratic formula would work, but there's an easier way for this problem. Okay, anybody who's in Algebra 2? How do you solve that? Thank God. Yes, so what do you do first? Okay, so whether you're doing quadratic formula or whether you're factoring, you need to get the equation equal to 0. Okay, so you need x squared minus 6. Oh, sorry. We're going to put it in standard form also. I'm going to subtract the x over. So minus x minus 6 equals 0. You want to get it equal to 0, and you want to put it in standard form, which means you want the square term, then the linear term, then the number. Okay, so the x squared term, then the x term, then the number. Okay, so quadratic formula would work, but that's longer because this one is factorable. So when you're factoring, you're looking for, you're trying to break that up into 2 sets of parentheses. Okay, and you're looking for 2 numbers that are going to, let me do this first. To get x squared, in the first slot here, we'd have x times x. That'll give us x squared. Then we're looking for 2 numbers that will multiply to -6 and that will add to -1. Okay, so this is going to be the product needs to be -6, and the sum of the 2 numbers is -1. Okay, so what are the 2 numbers that when you multiply them, you get -6, and when you add them, you get -1. These are the numbers that'll go in these spots here. Philip? -3 and +2. Now, with these, we're always going to check. You don't necessarily have to write down the check. You can do a mental check, but we're always going to check and make sure that it works out when you factor it back. So x times x would give you x squared. X times 2 is 2x. That'll be -3x. And then -3 times 2 is -6. So when you combine that, the like terms together, you'll have that, which is what we started with. Okay. So that's just a check, and you always want to do a mental check whenever you're factoring to make sure you have the right number. So like, for example, if you put +3 and -2, then maybe you would catch that down here when you got the wrong middle term. So you always want to do a quick mental check and make sure that makes sense. Okay, now the reason that factoring is helpful is because it's going to say the 2 numbers easily. So if 2 numbers multiply to be 0, that means one or both of them have to be 0. Right? The only way you get a product of 0 is when you do 0 times something. It might be 0 times 0, or it might be 0 times another number. But this one would give you x equals 3. This one would give you x equals -2. Okay, those are your 2 solutions. These are your two solutions to that quadratic. Okay, now the answer to the problem was 6. Clearly, we didn't get 6. So what do we have to do now? Plug it in. Okay. So what do you notice when you plug in 3? So if x is 3, then this would be 3 squared minus 6. That's 9 minus 6. That's also 3. That's good. How long is AB? 6. Oops, lost my, got my x squared in there by accident. Okay, so that's the answer they had. Why is there not a second answer on this problem? Jake? Okay, so typically that happens with geometry problems. Usually when you have a quadratic, in algebra, you almost always get 2 answers, the only exception being if it was 0, or a repeated value. But for a geometry problem, almost always you'll have one answer that works and one answer that doesn't work. It is possible to have like 2 different pictures that would both work, but usually it doesn't happen. Usually one of them gets thrown out. So this one gets thrown out because length cannot be negative. Yes, it could be equal to 0. No, it really won't be on these problems. So if you try to put in -2 right here, that's not going to make sense, right? The length can't be -2, so that one gets thrown out. So that's why your answer is just AB equals 6. Okay, we're going to go ahead and check 3-5 problems and talk about those. There weren't as many of those, so check those and see. Did we talk about the 3-5 lesson? Like the homework over 3-5. Did we check that yet? That would have been homework number 32. I don't think we did because I didn't see you online on day 7, right? I don't think we've gone over that one either, so. These are 3-5 from the book. This is still homework 33. So 15C asks the relationship between angle 6 and angle 8. You could either say they're congruent or that they're vertical angles. It was a little open-ended, a little vague, so either of those would be fine. Jay? Okay. Okay. Raise your hand if you need more time checking answers. Still checking? Okay, that's fine. I have the problem, I've screenshot the problems down below, but I'll give you a second to finish checking before I scroll down. Any other problems you want me to discuss? So, 23, okay. Yeah, so let's go down and talk about some of these now. So number 15, which angles are exterior angles? Now, the definition of exterior angle is it's an angle that's formed by 2 sides of a triangle, one side and then an extension of another side. So that makes angle 5 an exterior angle, but angle 4 is not an exterior angle. Okay, that's only formed by extending one side. It's not touching the another side of the triangle. Okay, what's the theorem about angle 5? The measure of angle 5 would be equal to what? The exterior angle theorem. What did that say? Measure of angle 5 equals. I talked to Nick a bunch of times. Somebody else talked to me. Leah. Okay, that's true. There are linear pairs that are supplementary, but I'm wanting the new theorem that was in this lesson. exterior angle is equal to the, the sum of angle 1 and angle 3. Okay, so the exterior angle measure is the sum of the, somebody started to say the names. What are those called? In relation to angle 5, they are the remote interior. Okay, the exterior angle is the sum of the two remote interior angles. All right, so angle 5 is an exterior angle. And then down here, a side of the triangle and an extension of another side makes angle 8 an exterior angle. And then a side of the triangle and an extension of another side makes 6 an exterior angle. 7 is not an exterior angle because 7 would require you to extend 2 sides. Okay, 7 is vertical to one of the interior angles. That's not an exterior angle. Okay, so the exterior angles are 5, 8, and I think that's a 6. Okay, and then number 14. So let's see, if this is a right triangle, okay, that is awful. Since that's a right triangle, the acute angles are complementary, which means this one is 60. And then since these are parallel and that's your transversal, that'll make this one also 60. So C is 60. Okay, and then number 23, I think was an algebra one. Okay. The measure of one angle of a triangle is 40. The measure of the other two angles are in a ratio of 3 to 4. So since the other two angles are 3 to 4, that means that you can say 3x plus 4x, and then plus your third angle, which is 40, equals 180. Or you can just say that 3x plus 4x equals 140, because if the third angle is 40, then the other two have to add to 140. So if 7x equals 140, then x equals 20. And that gives you the two angle measures would be 3 times 20 is 60, and 4 times 20 would be 80. So 60, 80, and 40 add up to 180. And those are in a 3 to 4 ratio. Okay, anything else from this assignment? Okay, that's 33. Let's go talk about number 32. Was the worksheet on 3.5? Okay, this is homework 32, and it was worksheet problems on 3.5. It's called like 3.5 practice G modified plus problems, something like that. Questions on any of those? Here's the bottom of that page. For this one, you maybe didn't think about the fact that in an isosceles, every isosceles triangle will have two angles that are congruent. Those are called the base angles. They're across from the congruent sides. So if you're looking at an isosceles triangle, it has two congruent sides. The angles across from them will be congruent. So that means in a right triangle, it'll always be 45, 45, and 90 because there's going to be two congruent angles that add up to 90. Nick. The you can say the measure of the two acute, or I'm sorry, the two acute angles are complementary. You could say something like that. Okay, questions on the first page, anything? No, go ahead. Okay, the ones that are ratio, that's like the one I did on the other thing. The ones that are ratios, you're just going to throw an X in there because it's saying that when you simplify it, it'll simplify down to 2 to 3. But there's some common multiplier. That's what makes the ratio 2 to 3. There's some common multiplier where you could scale it up by that factor and make it work out correctly. So the angle measures, the two acute angles in a right triangle are complementary. So you just say 2x and 3x adds up to 90. That'll give you x is 18. That's your multiplier. So you multiply 18 by 2 and get 36, and you multiply 18 by 3 and get 54. And so those two add to 90 plus your right angle. That would work out to give you the 180 in the triangle. Okay, anytime that they're talking about ratios, you just throw an X in there and make an equation. Okay, that's how you show me work. You gotta make sure you're able to write an equation for this. Okay. So the largest exterior angle is going to be the one that's beside the smallest interior. So that means you need to find that third angle measure so you can tell which one's the smallest, and the smallest is 39 degrees. And then here's the proof. Sorry. So remember that you're going to be using converses on number 2 and number 7. Okay, so you've got L and M are parallel, and that will give you that 1 and 3 are congruent because the lines are parallel. That makes the alternate interior angles congruent. So this one you're saying you know the lines are parallel. So if parallel lines cut by transversal, then alternate interior angles are congruent. Okay, we're using definition of congruent angles. Hopefully that was easy. When you're looking at where you're headed, you're trying to get that 3 and 2 add up to 180. So that means you want an equation where you can plug into that. Now they gave you that 1 and 2 are supplementary, which means that you're able to say that they add to 180. And that's an equation. Measure of 1 plus measure of 2 equals 180 means that you can now replace angle 1 with angle 3. So using that, we can put that in place of angle 1 and get angle 3. Okay, and then that means that because 3 and 2 are supplementary, the linear pair, the transversal would be L, and that means that these would be your lines that are parallel, with L being the transversal. Since 3 and 2 are consecutive interior and they're supplementary, that makes a parallel to B. So again, on that one, we're using the if you have consecutive interior angles that are supplementary, then the lines are parallel. So we're using converses on this. We're starting with the parallel lines here. We're ending with the parallel lines here. There are not going to be proofs on your quiz, but we will be doing some proofs for 3-3, and that's kind of what this is. This is using the 3-3 theorem there. Okay, so we're going to work through this problem. Hold on a second, let me see if I posted it. It might be in the 3-5 folder. Yeah, if you go down to the bottom of the page where it says chapter 3, and you can expand it out, in the 3-5 folder, I think that this is that. Let's see. Nope, sorry, wrong thing. Nope, that's not it. Okay, I take that back. All right, never mind. Just take a picture of that, and we're gonna work through this problem. You can put this at the bottom of that homework on 3-5, that'd be fine. Okay, when I had the other classes do this problem, some people were running into trouble not knowing what to do. So I want you to take a picture of that, put that into either its own notability document, or you can just paste it onto the bottom of your 3-5 homework and see if you can figure that out. Hey, Katie, I know that's a really weird angle. I'm just gonna take a picture of my screen. Better. Sorry about that. Okay, let's go over this one. So which angle is next to your angle? You just need to make sure that you name that properly. So angle ACD, you have to have 3 letters. You can't just say angle C because there's 2 different angles with the vertex at C. All right, its remote interiors would be, and you can call those angle A and angle B. If you want to use the long name for angle B, that's okay, but it would be all right to call those angle A and angle B, or angle A and angle ABC. Okay, now we need an equation to solve for x. Someone who hasn't talked to me today, give me an equation to solve for x. Jake. Emma, what's wrong with that? Okay, so if you had that equation, Jake, it wouldn't be this angle out here. Where would 12x minus 21 be? If you added this angle, and 12x minus 21 to equal 180, where would the 12x minus 21 have to be, Katie? Okay, back up 1 second. I want to know if Jake had written the equation like that, where would 12x minus 21 have to be to make it equivalent? Yes, it would have to be that angle right there, right? And then it'd be the 3 angles out of 180. Okay, so that can't be those adding up to 180 because, okay, now that, you have to be careful about that because you can't just throw an x on there because we don't know how that x relates to the other expressions. If you want to put a variable there, you put a y. If there's already an x in the problem, you can't just throw an x in as a variable because x is already determined by whatever expressions there were. So x is not actually a variable. X is a value that you just haven't figured out yet, but that we would actually know the value of. Okay, so Katie, you were going to say do what? Like that? Okay, so let's pause on that for a minute and go back to Emma. What did you say the equation should be, according to what you were going to say? Okay, what equation is, or what theorem is that? Okay, exterior angle theorem says that the sum of the remote interiors is equal to the exterior angle measure. So we'd have what, 8x minus 1 equals 12x minus 21. So 4x, sorry, I'm having a little messiness here. 4x equals 20 and x would be 5. Okay, it asks you to find the angle measures. So the angle measures would be 25 minus 8 is 17. That's 5 times 3 is 15 plus 7 would be 22. So what would this angle measure, what should that angle measure come out to be? 39. And that's the same thing if you do 12 times 5 is 60, and 60 minus 21 should be 39. So your x value is 5. Those angle measures should be like that. And then what would that interior angle measure in there be? Elliot, what would that angle measure have to be? What would this angle measure have to be? $141. Okay, now let's go back to, sorry. Let's go back to this other equation and check its solution. So if we try to find the supplement of the 12x minus 21 and work that out, let's see what happens. So Let's see, that's 8x minus 12x is minus 4x. You know what, I'm just going to go ahead and subtract that 180 on both sides to make it disappear so I don't have to mess with it. So just get rid of that, okay? That would be 8x minus 12x is negative 4x. And then there's negative 1 minus 21 is minus 22 equals 0. Four x equals negative 22. It's not the same thing as what we got down here. What is happening up here? Why is that not giving us the right answer? So the idea that this angle is supplementary to that angle, so if you find the supplement, those should all add up to 180. That's the correct idea. But there's something wrong with this equation. Let me go back to what it looked like back here. What is wrong with this equation? So we have 3x plus 7, we have 5x minus 8, and then we have 180 minus 12x minus 21. What's wrong with that equation? Katie, you're the one who said it, so did you figure out what's wrong with that? Okay, you said something about parentheses. If I put parentheses in there, then this would be a correct equation. Tell me where there should be parentheses. Like this? Okay, that actually wouldn't change the equation because when you're adding, the order of adding doesn't really matter. That's not where the parentheses go. Where did the parentheses go? Anybody besides Nick? Jack? Like this? That wouldn't change anything because it would just mean you're adding those together, which you already could have done. Yeah. Okay, that's what Katie said originally, and that wouldn't actually change anything because you're just doing those first before you add the other things, and adding and subtracting doesn't really matter about the order. Katie? Like this? That wouldn't change anything either. Nick? Tell me exactly what to put parentheses around. Okay, here's the problem. When you told me that you wanted to find the supplement of 12x minus 21, Philip, say it again. Because why? There needs to be parentheses there, right? So if this was an expression for the exterior angle, the supplement of that is 180 minus that quantity. So it should actually have turned into positive 21. So this would, I'll take out that 180 again here, but that would become 8x minus 12x here, but that's plus 21. And then when you do the 21 minus 1, this becomes minus 20. Okay, and then, sorry, plus 20. And then it would be, yeah, let me do this over. We combine like terms here. So this is equal to 0. We combine like terms. We have 8 and negative 12 is negative 4x. And then that's negative 1 plus 21 is plus 20. So 20 equals 4x and x is 5. Now, moral of the story, don't do it that way, okay? what happens, there's always a couple of students that try to do it this way and then they forget the parentheses and then they get the wrong answer and they're like, I don't know what I'm doing wrong. It is much easier to just use the exterior angle theorem. Okay, the exterior angle is the sum of the two remote interiors. Don't even mess with the supplement. But if you're going to mess with the supplement, do it correctly. If you're going to mess with the supplement, you have to say 180 minus whatever that exterior angle expression is. Otherwise, it's not going to work out. So you have to have a parentheses so that that negative distributes. Okay, this is easier. I would do it that way. But if you insist on doing the triangle angle sum theorem, make sure you know how to do it correctly. Okay, we have one more homework to go over. This is 31. Sorry, I know that this is a lot, but gotta make sure you understand the stuff that you did since I've seen you last. Okay, so this is 31. This is book problems on 3.3 and 3.8. Book problems on 3.3 and 3.8. That's 13 through 16 top. Now remember that all of these are figure out the x that would make the lines parallel. Okay, what's the value of x that would make the lines parallel? You weren't given parallel, you're trying to conclude parallel. Okay, if such and such is true about the angles, then the lines are parallel. Okay, so we would need 55 equal x plus 25, or we would need those two to be equal. Questions on the first floor? Jake? Because here's the 17 through 20, 17 through 22, and then 26. And again, I told you I'd like you to write the theorem that explains why those lines are parallel. So there should be, for each of these, the lines that are parallel and then the reason. So remember that vertical angles have nothing to do with parallel lines. So if I told you some angles were vertical, that doesn't mean you have any parallel lines there. Vertical angles are always congruent, so that won't make any lines parallel. That's just always true. Just like linear pairs are always supplementary. Linear pairs are always supplementary, so that does not mean anything about parallel lines. Yeah. 7 and 9. Yeah, so because they're not directly related, we couldn't say if there's any parallel lines there. There's not one transversal that relates them to each other. Any other questions on the that first page of first with the problems? Here's the two at the bottom. Again, like this one, when I use the vertical angles are congruent, I am not assuming anything about parallel lines, right? Those vertical angles are always congruent. But in order to make the lines parallel, I would want to know that these angles are supplementary. So if those angles are supplementary, then that would make the L and M parallel to each other. But I'm using two different reasons there because those angles aren't directly related in terms of L and M. So if it's helpful to kind of, if it's helpful to kind of look, all right, L and M are my lines I'm trying to prove parallel. So just look at one transversal at a time. Like I'm looking at this one and I'm saying, okay, I don't need to know anything about 27x. I'm just going to use the angles over here. Okay, and then for that one, linear pairs are always supplementary. Okay, so if I knew that these corresponding angles were congruent, the linear pairs would have to be supplementary. So then when I add those to 180, I'd get x equals 20. Okay, but what I'm trying to use that's not given is I need to know that the corresponding angles are congruent. Now, there could be another way of you doing that. So you could use like alternate interior with a linear pair. So you could use like if the alternate interior angles were congruent, then the lines would be parallel along with the linear pair. You use the linear pair here. So there's more than one way to do that problem. Any questions on those two? It's really important that you get down the difference between concluding the lines are parallel and starting with the lines being parallel. All right, and then we're finally to the end here. So this is a 3-7 problems. Try to meaning like the graphs, is what you're saying. So if you do this, that's okay, but what you need to do is make sure that I'm able to tell, you know, like where that point is, and then do this, up 1 over 1, up 1 over 1, whatever. Okay, I generally will give you graphs. There's also, over here, there's also a graph paper where if you're wanting to graph, you can make a page of graph paper down there, okay? Sorry, let me change that too. Okay, so here's everything from that lesson.